Chapter 1.5.8 IPv4 IPv6 Dual Stack. Kubernetes version 1.23 now supports dual stack networking, allowing the allocation of both IPv4 and IPv6 addresses to pods and services. This feature is enabled by default in Kubernetes clusters starting from version 1.21, enabling the simultaneous assignment of both types of addresses for greater networking flexibility. Supported features. IPv4 IPv6 dual stack on a Kubernetes cluster allows for dual stack pod networking with both IPv4 and IPv6 addresses per pod, IPv4 and IPv6 enabled services, and off-cluster egress routing through both IPv4 and IPv6 interfaces. This feature enhances connectivity and flexibility within the cluster. Prerequisites. In order to utilize IPv4 IPv6 dual-stack Kubernetes clusters, certain prerequisites are required. These include having Kubernetes version 1.20 or later, provider support for dual-stack networking, and a network plugin that supports dual-stack networking. It is important to check the documentation for earlier versions of Kubernetes if using dual-stack services with those versions. The provider must be able to provide Kubernetes nodes with routable IPv4, IPv6 network interfaces. Configure IPv4, IPv6 dual stack. To configure IPv4, IPv6 dual stack, set dual stack cluster network assignments for various Kubernetes components. The Kube AP server, Kube controller manager, Kube proxy, and kubelet all have specific flags to set the IPv4 and IPv6 CIDR ranges. For bare metal dual stack nodes, the node IP option is required if not using a cloud provider. Legacy built-in cloud providers do not support the node IP option for dual stack configurations. Examples of IPv4 and IPv6 CIDR ranges are provided as references. Services. Services in Kubernetes can use IPv4, IPv6, or both address families. The address family of a service defaults to the first service cluster IP range configured in the Kube API server. When defining a service, you can configure it as dual stack by setting the .spec.ip family policy field to specify the behavior you want. There are three options for this field: single stack, prefer dual stack, and require dual stack. In scenarios where dual stack configuration is required, options can be set in the spec.ip family policy field. For example, setting prefer dual stack will allocate both IPv4 and IPv6 cluster IPs for the service when dual stack is enabled. If dual stack is not enabled or supported, it will fall back to single stack behavior. The .spec.ip families field, which is conditionally mutable, allows you to add or remove a secondary IP address family, but cannot change the primary IP address family of an existing service. The values for .spec.ip families can be IPv4, IPv6, IPv4, IPv6 dual stack, or IPv6, IP4 dual stack. The first family listed in the array is used for the legacy duck.cluster IP field. Examples of dual stack service configurations, including default settings for new and existing services, as well as scenarios for switching between single stack and dual stack configurations are provided. When enabling dual stack on existing services, the control plane will set .spec.ip family policy to single stack and spec.ip families to the existing services address family. For headless services without selectors, the .spec.ip family policy defaults to require dual stack. To provision a dual stack load balancer for a service, the .spec.type field must be set to load balancer, and the .spec.ip family policy field should be set to prefer dual stack or require dual stack. It is important to note that cloud providers must support both IPv4 and IPv6 load balancers for dual stack load balancer type services. Egress traffic. To allow a pod using non-publicly routable IPv6 addresses to reach off-cluster destinations like the public internet, enabling egress traffic is necessary. This can be accomplished by giving the pod a publicly routed IPv6 address through mechanisms like transparent proxying or IP masquerading. The IP Mask Agent project supports IP masquerading on dual-stack clusters, but it is important to ensure that your CNI provider supports IPv6 before implementing this setup. Windows support. Kubernetes on Windows does not support single-stack IPv6-only networking, but does support dual-stack IPv4 IPv6 networking for pods and nodes with single-family services. IPv4 IPv6 dual-stack networking can be used with L2 bridge networks, but overlay VXLAN networks on Windows do not support dual-stack networking. More information on different network modes for Windows can be found in the Networking on Windows topic.